Hello and welcome back to another LeetCode problem. We're looking at LeetCode 3392, count subarrays of length 3 with a condition. Ooh, it's an easy problem, and I'm currently going through a bunch of easy problems, and I'm using them to practice my interview communication skills. So I will find a solution live. I have not tried this before, and I hope I will explain it well as well. So that's why I'm picking an easy problem, because with medium problems, it's a little bit more difficult. And when you get stuck, well, you also get stuck, practicing kind of the regular interview process. Obviously, there are techniques to deal with getting stuck, but that's not what I want to do right now. I just want to focus on the process, on the happy path. Right, so, well, step one is, in an interview, understand what the problem is. Given an integer array nums, return the number of subarrays of length 3 such that the sum of the first and the third numbers equals exactly half of the second number. I have to read that again. So given an integer array nums, return the number of subarrays of length 3 such that the sum of the first and the third numbers equals exactly half of the second number. What? Okay, I think we'll find explanation for that in a second. So next step 2 is understand the constraints. So, well, we given an array nums. I want to know what values are in there. I want to know min max values. I want to know whether it can be empty, all of those good things. So here on LeetCode, we can see that in the constraint section. So it's guaranteed that nums contains at least 3 numbers, and we have positive and negative integers, I suppose. Right, so step 3, well, go through an example to understand the problem, which is what I need right now. So here we have an input array of numbers 1 to 141, and the output is 1 for some reason. So let's understand it. Only the subarray 141 contains exactly 3 elements, where the sum of the first and third number equals half the middle number. Oh, I see. Excuse me. So that makes it easy. I understand it now. So in the next example, the only subarray with 3 elements is 111, but of course 1 plus 1 is 2, and that is not exactly the half of the middle element, which is 1, and the half of it would be 0.5. All right, so I guess what we can do is, well, we just iterate over the array with a sliding window of size 3. And every time we find a subarray that fulfills the conditions, or like our sliding window fulfills the conditions, that means we increase our counter, our result counter, by 1. So that's what we're going to do. It's going to be O of n time and O of 1 space for the result. And so in an interview, I would now ask for buy-in from the interviewer. Is it okay for me to implement? Or do you have any questions? Any other suggestions? And then they say yes, implement it. O of n time and O of 1 space. Right, so we're going to use let's use an index. You don't have to keep the elements in an actual window, but like a virtual one. So for I in range, well, let's start at index 1, because we want to be able to access, I guess, the predecessor. And we want to go up into range of nums, but maybe -1, so that we can actually access the successor of the element at position as well. So now we do if, well, nums at position I -1 plus nums at position I +1 is exactly half of is equal to nums at position I, but exactly half of it. So that's the same as multiplying the sum of the outer two elements. That is equal to nums. Then, well, then we increase our result counter, I guess, variable, which we have to initialize with a value as well. And at the end, we have to return it. Cool. And I think that's the whole thing. That's the whole solution. And nums divided by 2. So that's, I think we should do it this way, because if I do a division here, well, that's a float. Should I do integer division? Maybe I get like weird off by 1 errors. So I don't want to think about this, so I just write it this way. So let's run through the test cases down here. And we have an error because num is not defined. It is supposed to be called nums. Cool. And the 2 test cases pass. So now let's submit our proposed solution to see if it works. And it does. Cool. And that is it.